Hey everyone, ready to get a little cosmic?
Always.
Today we're going to dive deep into how it all ends,
The end of the universe.
based on Katie Mack's The End of Everything.
Which, let me tell you,
Yeah,
is a real page-turner.
it is. It's a wild ride.
Through black holes,
Dark matter.
and maybe even the universe ripping itself apart.
I mean, talk about an existential crisis, right?
You know what's even crazier?
Right.
Katie Mack's whole journey into this started with a really casual
Yeah?
astronomy class get-together.
Oh, really?
Like, imagine cookies,
Uh-huh.
tea,
Okay.
and the professor just casually mentions
Yeah.
that the universe could suddenly inflate into oblivion.
Just like that.
Yeah, like poof.
Wow, talk about a mood killer. I can't even imagine.
But, I mean,
Yeah.
it really sets the stage
Yeah.
for her book.
It does.
Like the universe ending,
Yeah.
not with a whimper,
But a bang.
but a bang or a rip
Crunch.
or a crunch.
Yeah.
Exactly.
So, okay, to really understand this stuff, though,
Yeah.
don't we have to start with what we actually know?
Of course, the Big Bang.
Right.
You know, this idea that the universe started as this super hot, dense point,
Yeah.
and it's been expanding
Right.
ever since.
So Katie Mack's book is basically saying, okay, Big Bang, we get it.
Yeah.
That's the starting point.
Uh-huh.
Now let's talk about the finish line.
The possible finish lines.
All the different ways this expansion could end.
And she doesn't shy away from any of them.
She really doesn't.
I mean,
Yeah,
some of these scenarios are wild.
they are. But before we get too far into the weeds,
Really?
let's talk about the evidence we have.
Okay.
The cosmic microwave background radiation.
Yeah. The CMB.
Like a baby picture of the universe.
Exactly. It's like this faint afterglow from the Big Bang that's been traveling through the universe
For billions of years.
for billions of years.
It's amazing.
And you want to hear something funny? It was discovered totally by accident.
Oh, come on.
Seriously, these two scientists,
Yeah?
Arno Penzias and Robert Wilson,
Okay.
they thought it was just interference in their telescope.
No way.
They spent ages trying to get rid of this annoying humming sound.
Ugh, I hate that.
And boom!
Yeah.
They realize it's this incredible piece of evidence.
Wow, a cosmic accident.
It is.
But what does it actually tell us?
It gives us a snapshot of
The-
the universe when it was super young.
Like how young?
Only 380,000 years old.
Wow, a baby universe.
And what's crazy is how uniform it is.
Uniform.
Yeah, imagine a perfectly smooth cake batter.
Okay.
That's basically the early universe.
Huh.
But there are these tiny variations.
Oh, is it not perfectly smooth?
Not perfectly smooth, more like a few sprinkles on top of the batter.
So those sprinkles, what are they all about?
Those tiny variations,
Yeah.
they were crucial.
Really?
They acted like seeds for everything.
What do you mean?
Galaxies,
Okay.
galaxy clusters,
Huh.
over billions of years.
Uh,
Gravity pulled matter together around those denser regions.
creating the structure we see today.
Exactly.
Wow, I never thought of it like that.
It's mind-blowing.
So these tiny imperfections
Yeah,
created everything.
pretty much.
Okay, so we've got this baby picture of the universe,
Yeah.
this smooth batter with a few sprinkles.
The seeds of the universe.
Oh, wait a minute. Isn't there a whole lot of stuff we can't even see?
You're talking about dark matter.
Yeah, like how much are we talking?
Oh, about 85% of all the matter in the universe?
85%.
That's right.
It's like this invisible scaffolding holding everything together.
A cosmic mystery.
So how do we even know it's there?
Think of it like this.
Okay.
You see a merry-go-round spinning super fast based on what you can see.
Uh-huh.
Those horses should be flying off,
Makes sense.
but they're not.
So something's holding them on.
Exactly. And it's the same with galaxies.
They're spinning too fast.
Way too fast.
For what we can see.
So there must be something we can't see.
Dark matter.
Dark matter providing the extra gravity.
Okay, that analogy actually makes sense.
Good.
It's like a cosmic puzzle where most of the pieces are missing.
That's a good way to put it.
And then to make things even more complicated,
Oh.
the expansion of the universe
Yeah.
isn't slowing down.
It's actually speeding up.
What?
Yeah, this discovery in the late 1990s really shook things up.
I bet.
It means there's another force out there.
Pushing everything apart.
We call it dark energy.
Dark energy, so it's like a cosmic tug of war.
Between dark matter
Holding everything together
and dark energy pushing it apart.
with the fate of the universe hanging in the balance.
That's a pretty good summary.
So how do they even figure out that the universe is accelerating?
It's all about these special exploding stars
Okay.
called Type Ia supernovae.
Supernovae, those are like...
Huge explosions
Yeah.
when stars die.
Right.
And the cool thing is, we know how bright they should be.
Okay.
So by measuring how bright they appear to us.
We can figure out how far away they are.
Exactly, like judging how far away a car is based on its headlights.
Oh, I get it.
Dimmer headlights, farther away.
So they looked at these supernovae, and they were dimmer than they should have been.
Much dimmer, which meant they were farther away than we thought.
Because the universe was expanding faster.
Exactly. The expansion was accelerated.
So the universe is not only expanding,
Yeah.
it's doing it faster and faster.
That's right.
And this is all because of this mysterious...
dark energy.
that we barely understand.
One of the biggest mysteries in cosmology.
Okay, so we've got this cosmic tug of war.
Between dark matter and dark energy.
And depending on which one wins.
The universe could end in a few different ways.
Okay, this is where it gets really interesting.
It does.
What are some of the scenarios Katie Mack explores in her book?
Well, one possibility is the Big Crunch.
Okay, that sounds dramatic.
It is. Imagine the expansion reversing. Yeah.
Everything collapsing back in on itself.
Like a cosmic implosion.
Yeah, galaxies colliding, stars getting ripped apart, the universe ending in this fiery singularity.
It's like a giant cosmic game of reverse Jenga.
I liked that.
So that's one option, but is there another scenario where things just fade away?
Yeah.
The heat death?
The heat death, that sounds a little less dramatic.
It's a slow fade to black.
Okay.
The universe keeps expanding,
Uh-huh.
getting colder and colder.
And emptier.
Stars burn out.
Black holes evaporate.
Everything decays into this diffuse sea of radiation.
So those are two pretty heavy options.
The Big Crunch and the heat death.
But I have a feeling you've saved the most intense one for last.
You're right.
What is it?
The Big Rip.
Oh, that doesn't sound good.
It's not.
So what happens?
Imagine the universe being stretched and pulled
Yeah.
faster and faster until everything rips apart.
Everything.
Galaxies, stars, planets, even atoms.
Wow, that's intense.
It's the most violent end.
So we've got the Big Crunch, the heat death, and the Big Rip.
3 possible endings.
All billions of years in the future.
Probably.
But is there anything that could wipe us out sooner?
Well, there's this idea called vacuum decay.
Vacuum decay, that sounds ominous.
Remember that casual astronomy class discussion Katie Mack had?
The one about the universe suddenly inflating?
That's the one.
Okay, vacuum decay, tell me more.
It involves this thing called the Higgs field.
The Higgs field? That rings a bell.
It's this energy field that gives particles their mass.
So, like, it makes things heavy.
You got it.
Okay, I'm with you so far. But how does this lead to the universe ending?
The Higgs field might not be in its most stable state.
So it's like unstable.
It's like a ball balanced on a hilltop.
Oh.
Stable for now.
Yeah.
But any little nudge.
Could send it rolling.
Exactly. And that nudge could be anything.
Like what?
A high energy event, maybe a black hole evaporating.
Okay, and then what happens?
It creates this expanding bubble.
A bubble of what?
It's called true vacuum.
True vacuum. What does that even mean?
It means the Higgs field is transitioning to a lower energy state.
And this bubble, what does it do?
It travels at the speed of light.
Okay.
And within it, the laws of physics as we know them cease to exist.
So, like, everything gets erased.
You could say that.
And we wouldn't even see it coming.
Not a chance. It travels at the speed of light.
Wow, that's terrifying.
It's a cosmic reset button.
So somewhere out there could be a bubble of doom.
It's possible.
Heading straight for us.
You never know.
Okay, I'm officially freaked out.
I know, it's a lot to take in.
But even if this vacuum decay thing is unlikely,
thankfully, it's incredibly unlikely.
it really makes you realize how fragile everything is.
It does.
And how powerful these forces are.
They're forces that govern the universe.
Forces that we're only just beginning to understand.
Exactly.
Okay, so we've got these 4 ways the universe could end.
The Big Crunch, the heat death, the Big Rip, and vacuum decay.
What other mind-bending theories are out there?
Well, there's this idea of extra dimension.
Extra dimensions, like more than up, down, left, right.
That's right. What if our 3-dimensional universe
Yeah.
is just a brain floating in a higher dimensional space?
Wait, so our entire universe is like a sheet of paper
In a much larger space.
that we can't even perceive.
That's the idea.
My mind is blown.
It's a wild concept.
But how does this tie into the end of the universe?
Well, there's this model called the ekpyrotic model.
The ekpyrotic model.
Okay, where our universe could collide with another brain.
Like two sheets of paper slamming together.
Exactly. And that collision
Yeah.
would create a Big Bang-like event.
So you're saying the Big Bang might not have been a one-time thing
It could be a repeating cycle,
of cosmic collisions.
creating and destroying universes.
Wow, a never-ending cycle of big bangs and big crunches.
It's a possibility.
But how do these collisions actually create a universe?
The energy release
Yeah.
from the collision
Yeah.
creates the hot, dense conditions of the Big Bang.
So it's like a cosmic reset button.
Sort of.
So we've got this idea of a cyclic universe
Yeah.
constantly being reborn.
It's a pretty amazing concept.
It is, but aren't there some problems with that idea?
You're thinking about entropy.
Entropy, the tendency for things to get more disordered over time.
Exactly. If the universe keeps bouncing back,
Yeah,
shouldn't entropy build up?
that makes sense.
Eventually, you'd have a universe that's too disordered for anything complex,
So like a photocopy of a photocopy
getting blurrier with each copy.
until you can't make out the image anymore.
That's a good analogy.
So that's a big challenge for the cyclic universe theory.
It is, but some theorists have proposed ways around that.
Like what?
Maybe there are mechanisms that reset entropy with each cycle.
So the universe could keep bouncing back forever.
It's a possibility.
That's incredible. But how do we test these theories?
One way is to look for primordial gravitational waves.
Gravitational waves, those are ripples in space-time.
That's right. And these primordial ones
Yeah.
would have been created during the very early universe.
So like echoes from the Big Bang.
Exactly. They could tell us about what happened.
In the universe's first moments.
And maybe even before the Big Bang.
Wow. So how do we detect them?
One way is by studying the cosmic microwave background radiation.
The baby picture of the universe.
Exactly. Gravitational waves from the early universe would have left a unique mark,
On the CMB.
like a cosmic fingerprint.
So we're looking for these fingerprints in the CMB.
It's incredibly challenging.
I bet.
But there are experiments like BICEP and Planck
Guy.
trying to do just that.
So we're listening for the faint whispers of the universe's birth
Searching for clues about how it all began.
and how it might end.
Exactly.
That's pretty amazing.
It is.
And even if we don't find these primordial gravitational waves,
Yeah.
it doesn't mean the theories are wrong.
It just means we need to keep searching.
Keep pushing the boundaries of what we know.
That's the spirit of science.
I love it. This is why I love talking about this stuff.
Me too.
Okay, so we've explored these amazing theories,
About the beginning and the end of the universe.
but how do they connect back to us?
That's a great question.
Like, why should we even care about all of this?
It's all about the interconnectedness of physics.
Okay, what does that mean?
The laws of physics that govern those distant stars and galaxies,
Yeah.
they're the same laws that operate right here on Earth.
So by studying the universe,
We learn about ourselves.
that's pretty profound.
It is.
But how does studying the universe connect to our daily lives?
Take gravity, for example.
Yeah.
Newton's laws of gravity work fine here on Earth.
Yeah.
But when you start talking about black holes, or the universe as a whole,
Yeah.
you need Einstein's theory of general relativity.
Right. The warping of space-time.
And guess what?
Right.
That theory is used in GPS systems.
Those ways.
Seriously. Those satellites orbiting Earth,
Yeah.
they have to take into account the effects of general relativity.
Wow. So Einstein's theory is helping us find the nearest coffee shop.
Exactly. It's like a hidden cosmic hand guiding our lives.
That's amazing.
And that interconnectedness extends to other areas, too.
Like what?
Particle physics
The study of the tiniest particles.
is linked to cosmology.
How so?
The conditions in the early universe
Yeah.
were so extreme
Yeah.
that they mimicked the high-energy environments in particle accelerators
So it's like looking back to the beginning.
to understand the ingredients of everything.
I see. So it's not just about satisfying our curiosity about the universe,
It's about understanding the fundamental laws of nature.
and maybe even leading to new discoveries.
That could benefit humanity in ways we can't even imagine.
That's inspiring.
It is.
Okay, let's get back to the end of the universe.
Okay.
You mentioned that scientists are trying to figure out which scenario is most likely.
That's right.
What are they doing?
One of the most important areas of research is dark energy.
The mysterious force driving the universe's acceleration,
Exactly. We still don't know what it is.
or how it works.
So scientists are trying to understand it better.
Okay, how are they doing that?
They're studying the expansion history of the universe.
So like creating a cosmic roadmap.
Yeah. tracing the universe's expansion back through time.
To see how dark energy has been shaping things.
You got it.
So we've got these large-scale surveys
Mapping the distribution of galaxies.
trying to understand how dark energy has been influencing the universe.
Precisely.
But you also mentioned particle physics.
Yes. Particle physicists are trying to uncover the nature of dark matter and dark energy.
We still don't know what they're made of.
It's like having a cosmic recipe with missing ingredients.
And they're searching for those missing pieces.
Through experiments and theoretical models.
So they're going deep into the subatomic world.
To find the building blocks of these cosmic mysteries.
That's incredible. This sounds like a lot of work.
It is, but the potential rewards are enormous.
So we've got these surveys and experiments
We're working together
to solve these cosmic puzzles.
It's a multi-pronged approach.
But what about the more philosophical implications of all of this?
You mean the existential questions?
Yeah, I mean, this stuff is pretty heavy.
It is.
Contemplating the end of everything.
Rare.
It can make you question the meaning of it all.
Absolutely.
But that's where philosophy comes in.
It helps us grapple with these big questions.
Questions that science can't always answer.
Like the meaning of life.
Right.
Or the purpose of existence.
So it's about finding our own meaning.
In the face of the universe's eventual end.
Even if it's a big crunch.
Or a heat death.
Or a big rip.
Or even vacuum decay.
Okay, I'm going to need a minute to process all of
I
that.
do have time.
This has been an incredible deep dive so far.
I'm glad you're enjoying it.
But we've only just begun to scratch the surface.
There's so much more to explore.
So what's next?
Well, in the next part of our deep dive,
Yeah.
we'll be delving into the ongoing research
Okay.
that's pushing the boundaries of our understanding.
Sounds good. I'm ready for more.
Me too.
We'll be right back after a short break,
Welcome back to our cosmic journey.
where we're exploring the end of everything.
And in this part,
Yeah.
we're going to look at how the quest to understand the universe's grand finale actually connects back to us here on Earth.
Wait, what do you mean?
It's all about
Yeah.
the interconnectedness of physics.
Interconnectedness.
Yeah.
Like how we might think of cosmology
Uh-huh.
as this study of distant stars and galaxies,
Yeah.
but the laws of physics that govern those cosmic processes,
Yeah.
they're the same laws that operate right here,
Really?
even in everyday objects.
So you're saying
I
that
know.
by studying these huge cosmic events,
Yeah.
we can actually learn about the laws of nature
Exactly.
that affect everything.
Even something as simple as a coffee cup.
Okay, I'm starting to see the connection.
Good.
But can you give me an example?
Sure, take gravity. We learn about Newton's laws of gravity in school,
Uh-huh.
and they work fine for most things here. Yeah. But when you start talking about massive objects,
Like black holes.
or the universe itself,
Right.
you need Einstein's theory of general relativity.
Oh, yeah, the warping of space-time.
That's the one. And what's amazing is that this theory, developed to explain these cosmic phenomena,
Yeah.
actually has practical applications in our daily lives.
Like what?
GPS.
You're kidding.
Nope. GPS systems wouldn't work without taking into account the effects of general relativity.
So Einstein's theory of gravity
Mm-hmm.
is helping me find my way around town.
It's like a hidden cosmic hand.
Guiding our lives.
You got it. And that interconnectedness
Yeah.
extends to other areas too.
Okay, like what?
Particle physics.
Particle physics, the study of tiny particles.
Yes. And it's deeply linked to cosmology.
How so?
Well, the conditions in the very early universe
Uh-huh.
were so extreme
Okay.
that they were similar to the high energy environments we create in particle accelerator.
Or like the Large Hadron Collider.
Yes, exactly.
So by studying the early universe,
Yeah.
we can gain insights into the fundamental nature of matter
It's like looking back to the very beginning.
to understand the ingredients of everything.
Precisely.
So studying the end of the universe isn't just about satisfying our curiosity
It's about pushing the boundaries of knowledge.
and uncovering the fundamental laws of nature.
And who knows?
Yeah.
Maybe even leading to breakthroughs
That could benefit humanity.
in ways we haven't even imagined.
That's amazing.
It is. It's a reminder that science is a
Yeah.
constantly evolving process
Always pushing the limits.
of what we know
Okay, so we've established the connection.
between cosmology and our everyday lives.
But let's get back to the end of the universe.
Sure.
You mentioned that scientists are trying to figure out,
Which scenario is most likely?
yeah, how are they doing that?
Well, a big part of it is studying dark energy
Dark energy, that mysterious force.
that's driving the accelerated expansion of the universe.
And we still don't know what it is or how it works.
So how are they studying it?
One way is by studying the expansion history of the universe.
The expansion history.
Yeah, like creating a cosmic roadmap.
Okay.
Tracing the universe's expansion back through time.
To see how dark energy has influenced things.
Exactly.
So we're talking about those large-scale surveys.
Like the Dark Energy Survey.
And the Vera C. Rubin Observatory.
Those are great examples.
These surveys are mapping the distribution of galaxies to understand how dark energy has shaped the universe.
It's like taking a series of snapshots.
Of the universe throughout its history.
Exactly.
And this will help them figure out
which scenario is most likely.
whether it's the Big Crunch
Or the heat death.
or the Big Rip.
Right.
But you also mentioned particle physics.
Yes. Particle physics is crucial too.
How so?
Well, particle physicists are trying to uncover the nature of dark matter and dark energy.
We still don't know what they're made of.
It's like having a cosmic recipe,
Yeah.
but we're missing the key ingredients
And they're searching for those missing ingredients.
through experiments and theoretical models.
Okay, so we've got these large-scale surveys
Mapping the universe,
and these particle physics experiments.
probing the subatomic world,
It's a multi-pronged approach.
to solving these cosmic mysteries,
But what about the philosophical side of things?
the existential questions.
Yeah, contemplating the end of everything can be pretty overwhelming.
It can definitely raise some big questions.
About the meaning of existence.
And our place in the grand scheme of things.
Science can tell us how the universe might end.
But it can't necessarily tell us what it all means.
That's where philosophy comes in.
It helps us grapple with these questions.
And find our own meaning.
Even in the face of the universe's eventual end.
So it's about embracing the mystery.
And finding our own way to make sense of it all.
Even if it's a little scary.
It can be.
But it can also be inspiring.
It can remind us to cherish the present moment.
And appreciate the beauty of the universe.
Even though it might not last forever.
Okay, I'm starting to feel a little more optimistic.
Good. It's not all doom and gloom.
So what about civilizations that might exist billions of years from now?
That's an interesting question.
How might they react to the universe's end?
It's hard to imagine.
I know, but it's fun to speculate.
It is. Imagine a civilization facing the inevitable end of everything.
Wow, yeah.
How would they react?
What would they do?
Would they try to preserve their knowledge?
Or find a way to escape?
Or would they just accept their fate?
Those are some big questions.
They are. And they might seem far-fetched.
Yeah.
But they highlight the incredible potential of life and consciousness
To adapt and evolve.
in ways we can't even imagine.
Okay, I'm ready to dive into those possibilities.
Great, because in the next part,
Yeah.
we're going to explore some mind-bending ideas.
About how life and consciousness might persist.
Even as the universe fades away.
Okay.
Ready for more mind-bending stuff.
Always. We've talked about how the universe might end.
Big crunch, heat death, big rip, even vacuum decay.
Right, but now...
Now we get to the really fun part.
Oh, there's more.
Oh, yeah.
Okay, hit me with it.
What if,
What if?
even though the universe ends, life finds a way?
Wait, really?
It's a possibility.
How?
We have to push the boundaries of what we currently understand
About...
about the universe, about life, about consciousness.
Okay, I'm intrigued. Lay it on me.
Picture this. A universe with no stars,
Okay.
no galaxies,
Right.
even black holes have evaporated.
That's it.
It's a bleak picture.
Yeah, it is.
But even in that cosmic wasteland, some theories suggest that
Correct.
life might find a way.
Okay, this I gotta hear.
One idea is digital consciousness.
Digital consciousness, what's that?
Imagine far in the future,
Yeah.
advanced civilizations
Okay.
uploading their minds
Never mind.
into virtual realms.
So, like, becoming digital beings.
Exactly.
But would that even be life?
It's a good question. But in a digital realm,
Yeah.
those beings wouldn't be limited by the same physical laws as biological life. They could potentially exist forever.
Even in a dying universe.
Even then.
But wouldn't they need energy?
Of course, even digital beings need energy.
Hey, so where would they get it from?
Maybe they could harness energy.
From where?
Sources we can't even imagine.
Like what?
Maybe manipulating space-time
I know
or
it.
tapping into quantum fluctuations.
Quantum fluctuations. Isn't that like...
The unpredictable world of subatomic particles.
Yeah. How could that power consciousness?
Remember, everything is fundamentally quantum.
Yeah.
Even empty space is full of activity.
It's like particles popping in and out of existence.
Exactly. An advanced civilization
Yeah.
could potentially tap into that energy.
To create a self-sustaining digital world.
It's a mind-blowing possibility.
It is. It's like building a life raft out of the fabric of reality.
And while it's highly speculative,
Uh-huh.
it shows us how much we still don't know.
About the potential for life to continue.
In ways we can't even imagine.
Okay, so digital consciousness.
One possibility.
Are there others?
What about the multiverse?
The multiverse. Like parallel universes.
Maybe our universe is just one of many.
Each with its own laws of physics.
And its own possibilities for life.
So while our universe is ending,
Other universes could be thriving.
maybe even with life we can't comprehend.
That's right.
Wow, so even if everything ends here,
The cosmic story could continue.
in other universes.
Oh, that's a pretty amazing thought.
It is. So even with the heat death,
Or the Big Rip.
there's still hope.
Maybe even a chance for advanced civilizations to travel between universes.
Like interdimensional travel.
It would require unimaginable technology.
Right, like bending reality.
Mastering energy and matter on a cosmic scale.
Okay, my brain is officially overloaded,
It's a lot to take in.
but it's incredibly to think
About the potential,
for life to persist.
even in the face of the universe's end.
It really speaks to the power of life
To adapt and evolve.
and the mystery of the universe.
It's a universe we're only beginning to understand.
That brings us to the end,
Of our deep dive.
into the end of the universe.
It's been quite a journey.
It has, from the Big Bang.
To the potential demise of everything.
We've explored so
The
much,
science, the philosophy, the research.
and even the
The new
possibility,
life finding a way.
even after the end,
It's a testament to human curiosity
to our desire to understand the universe.
and our place in it.
I think I can speak for both of us when I say this has been an incredible journey.
It has. And we've only scratched the surface.
There's so much more out there to discover.
Keep looking up at the stars.
Keep asking questions.
Never stop exploring.
Thanks for joining us on this cosmic adventure.
We hope you've enjoyed the ride.
And until next time, keep wondering about the universe and all its mysteries.